Hello and welcome to another IB Mathematics video. This one we're going to be talking about sets. And what are sets? Well, sets are a group of things. So when we have anything and we just group it together, we call it a set. You can have your people in your class can be your set, for example, or people in your apartment block can be your set. And we use this for multiple things in real life. We have all sorts of different kinds of sets of things. So what we do with these sets is we put them inside. Sometimes these sets will overlap. So you might have a set which is the people in your class, and another set which is the people in your neighborhood. And there will be people in your neighborhood who are not in your class, and there will be people in your class who are in your neighborhood, and there will be people in your class who are not in your neighborhood. And therefore you can see that there's an overlapping. So the main way in which we represent sets is this very visual, very appealing way, which is called a Venn diagram. And here you have a Venn diagram. And you probably have seen these in multiple situations, such as the one I have here as an example. So the way it works, imagine that you have a list of all the universities in the world, and you put the ones that have a good reputation inside this circle, the ones that are affordable and you can easily pay in this circle, and the ones that have a feasible access and are easy to access, you put them here. And you start to look for which are the ones you're interested in, and obviously there's going to be some that have a good reputation, but it's not going to be possible to access, and they're not going to be affordable. Some American universities might fall in there; they're very expensive. Some of them are going to be affordable, but not going to have a good reputation, or are even not going to be easily accessible, etc., etc. So you might have that. For example, if you fall in these ones here, they have a good reputation and a feasible access, which is very good, but they're not affordable. You're not going to be able to pay them. These ones here, they can have a good reputation and they're going to be affordable, but you're not going to be able to get in. And these ones here, you're going to be able to get in, you're going to be able to pay it, but no one will take your degree seriously. So what you're looking for is stuff here that has a good reputation, has feasible access, and is affordable. So this is an example of how a Venn diagram works. So you can imagine where you could just imagine to place how you would place different universities in this Venn diagram, and it's an example of how these things work and what they are for. So here's another example. Another Venn diagram. This is a little bit of a joke, and I just put this one here because I want to explain what this symbol means. This symbol means that it's empty. There is nothing there. So this is just a little joke. It's not realistic about what happens sometimes when you go and set an exam and how one feels about it. So let's do some mathematics with this Venn diagram stuff, because I think that at the end Venn diagrams are very, very visual. But when we start to use numbers, somehow it gets tricky. So let's just sit back and think deeply for a second, because this is going to be something we have to understand clearly. Suppose we have drinks in a supermarket, and we check, which way they're packed, and we have some of them are put in cans, some of them are put in bottles, and some are put in both cans and bottles. Very popular drinks you'll find in the supermarket, both in a can and in a bottle. Some of the stuff like juice will be in a bottle but not be in a can, etc., etc. So when you go inside a small supermarket, and you find that there's some drinks that are canned, some drinks that are bottled, some drinks that are both bottled and canned. Now, here's a Venn diagram that represents the situation. And I ask you the question, how many soft drinks are not bottled? Well, all drinks that are bottled are here, so any number that's outside of this circle are going to be drinks that are not bottled. We only have one number outside of this circle, so the answer to this question is going to be 5. And how many soft drinks are not canned? Well, it's going to be exactly the different. It's going to be exactly the drinks that are outside of this circle, which are 12. So how many soft drinks are both bottled and canned? That's another easy one. That's going to be this one here. It's going to be 3. But this is the one that's tricky, and I need you to think about this now carefully. How many soft drinks are canned? Well, the question, the answer people give and they're wrong is they say 5. The answer is everything that's inside this circle, and that's going to be 5 plus 3. So the answer to this one is going to be 8. This is something that you have to keep in mind, because when exercises get more complicated, this is where people make mistakes, and Venn diagrams are easy. Really, you've seen them in real life. So just remember to always think carefully what you're going to do. And so this is a little bit of theory with Venn diagrams. Suppose you have a set. It could be anything. It could be universities, it could be friends, it could be bottles in the supermarket, and you have another one, B. And they overlap. They have a part where things are both in A and in B. There's stuff that's only in B and stuff that's only in A, but there's stuff that's in both. So the terminology we use is really not that difficult, and you've already seen some logic. Well, I don't know if you have, but if you have seen some logic, it's kind of similar, because in logic we had this one and we had this one for and or. Well, it's the same thing here. This means both in A and B, and it's just going to be this part here. So this would be A and B. And this one here is going to be A or B. So it's going to be the whole thing. We call this the intersection, and we call this the union. So that's what this is called, unions and intersections. So this is very important to understand. This terminology is going to be in the exam guaranteed. No questions asked. For sure this is going to be in the exam. So you must know this way of writing things. Really not that difficult. Now, when you think about it carefully, when you think about the Venn diagrams carefully, you will have noticed something. If you think of, let's start with this one. If you think with probability of A or B, and I'm already using the probability thing here. We are going to be looking at probability technically a little bit ahead, but let's just imagine it's any set. I'm using the terminology of probability, but let's just imagine that it's just bottles in the supermarket or whatever. We have A or B here. Well, is it going to be, forget about this part here, is it going to be this plus this? Not really. It's going to be this plus this, because we don't want to add this part in the middle twice. So technically, what we're doing is what we want to find the probability of A or B. It's going to be probability of A plus probability of B minus the intersection, because we don't want to add it twice. When we're adding these two together, it's already going to be added twice, so we have to subtract it once. We're going to have added this part and this part, which is the same because they overlap. So we have to subtract it to be able to get the probability of A or B. And this is a formula that you're going to get in your formula booklet that is really necessary. It's not that hard to understand what's going on, and you're going to need it in the exam, guaranteed. So remember what it means. Remember what A or B means. Remember what A and B means, or the union and the intersection, whichever way you want to think about it. Remember what they mean, because it's going to be necessary. So that's really all there is with Venn diagrams, and all you do is exercises using this formula. And so let's take a look at them. Well, here we have a typical exam exercise with students having lunch in school today, and they just tell you like a bunch of stuff about what they had to eat and how many had this thing and how many had the other, and you just have to fill up a Venn diagram with it. And once you do that, you can start to figure out what the values they ask you for are. I want to point out the existence of this little z here, which sometimes you get this in an exam, which they put a square, and what happens is that they're showing the Venn diagrams for three things, and there's going to be a number outside. What this number means is that it's not in any of the other three, so it's just outside of the Venn diagram sets. So normally you have a number there. It could be very large, it could be very small, it could be anything, it could be zero. But But just keep in mind in the notation that sometimes you will get this. So in this exercise, all you do is fill up the Venn diagram, you fill up the numbers, and you work out what the values of x, y, and z are. It really is not that difficult. I do encourage you to look at it carefully. You will find lots of exercises like this on the internet and elsewhere, so you should practice with Venn diagrams. It's worthwhile to understand it because it is something that you see a lot in real life. Thank you very much for watching.